Hey everyone, and welcome to today's Explainer. We're diving into something you interact with dozens of times a single day, but probably never actually see. I'm talking about firmware. It's the totally invisible engine powering our entire modern world. And by the end of this session, you're going to understand exactly how it works. To make this complex topic super actionable and easy to grasp for beginners, we're going to follow a really clear roadmap. We'll start with the magic power button, then break down the step-by-step boot process, compare firmware to software, look at how it powers everyday devices, and finish up with future careers. Let's get right to it.
All right, section 1, the magic power button.
So picture this scene. You sit down at your desk, reach out, and press the power button on your premium laptop. For a split second, everything just seems to freeze, right? It's completely dark. But beneath that dark screen, an absolute flurry of activity is kicking off. It really makes you wonder what is actually happening deep down in the motherboard circuitry before your screen ever lights up.
Well, that brings us to firmware. Basically, firmware is this invisible guide made of specialized binary code, and it's stored safely on a physical BIOS flash chip right on your motherboard. Its entire job in life is to wake up your sleeping hardware and get it ready for you. Because, believe it or not, your operating system can't do a single thing until firmware paves the way.
Moving to section 2, let's break down this whole awakening process into simple, step-by-step actions.
The boot sequence is actually incredibly logical. First up, the central processing unit, or CPU, starts. That's the brain. Next is a really fascinating step called memory training, where the firmware initializes your RAM. And only after the memory is fully ready to go does the firmware reach out to wake up your solid-state drive. Once the brain, memory, and storage are awake, the firmware just keeps moving down its checklist. It detects your keyboard, which, by the way, is exactly why you'll often see the keyboard backlight flash on before the screen does. Then it initializes the display. Only at the very end of this whole sequence does it finally hand control over to Windows. And for beginners, here's a fantastic troubleshooting tip. If your computer turns on, but the screen stays completely black, you now know the boot process got stuck somewhere during the firmware's hardware initialization phase.
And hey, it's the exact same underlying logic for your smartphone. When you hit power, the battery sends juice to the processor, the firmware activates, and it makes sure your touchscreen and camera are ready. Firmware acts as the absolute critical bridge before Android or iOS can even think about loading. It controls everything first.
Okay, section 3. Now that we've seen the steps, let's clearly separate firmware from the software you're probably more used to.
The easiest way to think about it is this. Firmware talks to the machine, software talks to you. Firmware is stored in physical flash memory, it starts first, and it controls the hardware. Software, on the other hand, like Chrome, Photoshop, or your favorite game, is installed later on your hard drive. It only runs after the boot sequence finishes, and most importantly, it's what we humans actually interact with. A classic example of firmware in action is the BIOS running what's called the POST, or Power On Self-Test. Think of this like a pilot's pre-flight safety check. The firmware runs a quick diagnostic to make sure everything from your USB controllers to your PCI slots is safe and functional. If it passes, it moves to hardware detection and searches for a boot device. But if it fails, well, you're probably going to hear those dreaded BIOS warning beeps. Now here's an incredibly actionable takeaway for you. Never, ever ignore a firmware update. When you run an update, going from, say, version 2.10 to 2.20, it sequentially applies major benefits right beneath the operating system level. It patches fundamental security flaws, improves compatibility with new hardware, fixes deep-level bugs, and can even boost the base performance and speed of your device. So, moving on to section 4, let's zoom out from laptops and phones and look at how firmware powers almost everything around us. Because honestly, it's literally everywhere. It's seamlessly waking up the router in your living room, your smart TV, and even your washing machine. But more critically, it's the exact same foundational technology running life-saving medical equipment, ATM machines, traffic lights out on the streets, and advanced robotics. Every single one of them relies on a firmware chip. The automotive industry relies heavily on this too. If you look at modern luxury cars, they really aren't just mechanical machines anymore. They are basically highly complex computer networks rolling down the highway, consisting of dozens of firmware-controlled modules known as ECUs. These ECUs manage everything: your anti-lock brakes, engine control, airbags, parking sensors, and your whole dashboard infotainment system. We also see this vividly in the smart home space, or the Internet of Things. Firmware is exactly what allows your smart devices to actually be smart.
Whether it's your smart door locks communicating securely, Alexa listening for a command, or your thermostat and refrigerator automating your life, firmware provides the digital foundation for all of that communication.
And zooming way, way out to a macro level, think about the massive data centers that house the cloud. These facilities have endless rows of blue-lit Dell and HP servers, huge storage arrays, and complex network switches. To keep our global networks running safely at that unimaginable scale, these massive data centers rely entirely on automated firmware updates. Finally, we reach Section 5. With firmware being so universally critical, who are the people actually building it?
The answer is firmware engineers. And if you're fascinated by how things work, it is a highly specialized, incredibly cool career path. These engineers use a really specific set of skills. They debug BIOS systems, use Python for automation, and write the core code using embedded C. To do all this, they rely on specialized hardware tools like oscilloscopes and logic analyzers to literally bridge the gap between digital code and physical electrical signals. Because firmware is the absolute required starting point for any piece of technology, these brilliant engineers are heavily sought after. We're talking massive tech giants: Intel, AMD, NVIDIA, Apple. Every single one of them relies on firmware engineers to design the future of connected devices. I want to end on a thought that I think beautifully summarizes our entire journey today. Firmware is invisible, but without it, none of our smart devices would even start. It's truly mind-blowing to think about the billions of devices on Earth seamlessly waking up, connecting, and communicating, all because of this tiny invisible layer of code. Without this foundation, the modern world just wouldn't boot up. So taking all of this in, what everyday device are you going to look at totally differently now?